In this video, we will solve an interesting problem called Monte Carlo problem. It's actually a game, and the game goes like this. So there are three doors in this game, and behind one door there will be a car, and behind the remaining two doors there will be goats. Okay, and you are asked to pick one of the doors. Once you pick the door, the host will open a door which contain a goat and then ask you if you would like to make another choice. Okay, for example, let's say uh, uh, in this picture this third door is closed, but just imagine we have these three doors closed, and for simplicity let's just assume behind door 1 there is a car, behind door 2 and 3 there is a goat. Okay, now you are asked to, in step number 1, you are asked to pick a door, right? So let's say you have picked door number 2. Okay, and in step number 2, the host, who already knows which door contain the goats, which door contain the car, he will open one of the doors. Since you pick door number 2, which has a goat, the host will have only two options to choose, right? 1 or 3. Because he already knew that behind 1 there is a car, what he do is he or she open door number 3 to disclose there is a goat behind, right? Then he will ask you, hey, do you want to stick with your initial selection number 2, or do you want to switch to door number 1, right? Now in this problem we will ask what is the probability of winning this game, meaning winning a car, if you do not switch, right? And what is the probability if you switch? Okay, now let's see how the game goes, and then we will solve it using Monte Carlo simulations. Okay, first again let's assume we have car behind door number 1, we have two goats behind door number 3 and door number 2 and 3. Okay, now here we are doing 10 experiments, and in the first case let's say you are not switching, right? So you are sticking to your initial guess. Okay, so initially let's say you have picked door number 1. Okay, because door number 1 has a car, the host, he will either open door number 2 or 3 and then say, hey, do you want to pick the remaining one, right? So what the host did is he picked door number 3 and he asked you, hey, do you want to stick with door number 1 or do you want to switch to door number 2? Because in this case we are not switching, you stick to your initial guess, which is door number 1, right? So your initial guess and final option are the same, because you are not switching based on what the host has done, right? So for example, in second experiment, your initial selection is door number 3, and the host opened door number 2 and he asked, hey, do you want to stick with your initial option 3, or do you want to switch to the remaining option 1? You stick with your initial option, which is number 3. Okay, so it goes like this, right? So these are the initial options, and then the host picked one of the doors which has a goat behind. He asked you to switch if you would like to switch, but you did not switch, so your final option also the same as your initial option. Okay, now we'll come to the winning probability, etc. Here we have done only 10 simulations. By now you are already familiar why we need to conduct many number of experiments to get a right estimate of the probability, right? Now this is the second scenario. Let's say you are switching, right? For example, your initial guess is 1, the host has opened the door 2 which has a goat, and he asks you, hey, do you want to switch to door number 3, or do you want to stick with your initial option door number 1, right? Because in this case you are switching, so you are switching to door number 3, right? For example, here In the second experiment, the same thing happened, but in the third experiment, initially you chose door 2, host opened door 3. That means you have switched to door number 1, right? So this is your final option, right? So after host has opened a door, he gave you the option either to remain with your initial selection or to switch to the only remaining door. Okay, so the game goes like that. Okay, I hope this how it goes is clear to you, right? Now let's simulate this process. Now, so we have 3 doors, 1, 2, and 3. Now let's put car behind one of these doors and goats behind the remaining 2 doors randomly, right? So here I'm making a random choice on these 3 doors. So I'm picking just one door. In this case, it happened to be door number 1, right? So behind door number 1, we are putting a car. And then the remaining 2 doors should have the goats, right? So here I'm just using this set function from Python. So we cannot subtract list from list in Python. I mean, removing the common elements, right? Not the element by element subtraction. So what I have done is, so the doors, this has 1, 2, 3, and the car door, which is this one. So with this set operation, we are finding the remaining 2 doors, and then we are converting it back to list. So the goats are behind door number 2 and 3. So with this code, all we did is we have 3 doors, and we selected one of the doors for car and the remaining 2 doors for the goats, right? Now let's conduct the experiment. So we are writing a function here. Now we are going to run this experiment n number of times, and we give the user the option to switch or not. Okay, so we run this experiment first time with the user not switching, and second time with the user switching, and then we compute the probability without switching and with switching to find out which one is the best option to. Okay, now again, let's spend a bit more time on understanding this problem, right? So initially, the probability of winning this game is 1/3, right? Because we have total 3, and each one has equal probability, right? And the car is behind only one of the doors. So which means the probability of winning this game is 1/3, right? This is if you do not switch after the host has offered you to switch, right? Now, let's say the host has offered you. What is the probability if you switch? A probability of winning if you switch the door, right? Now, even though it's a simple problem, most people think the probability would not change because each door has 1/3 of winning probability. So whether the host has opened the door and give you the option or not, the probability of winning remain the same. So most people think whether you switch it or not, right? And some people think, okay, since one of the door is eliminated, now the car is behind one of these, let's say one of these doors. So the probability of winning now increased to 0.5. So increased from 0.33, which is 1/3, to 0.5, because now we have only 2 options, and the door and the car is behind one of these 2 doors, right? So both answers are incorrect, as you will see. Switching the door will actually increase the winning probability by another 1/3. So if you stick with your option, initial option, there is only 1/3 winning probability, and that's easy to understand, right? But had you switched, your probability of winning this game will be 2/3 as opposed to 1/3. Okay, it's a bit tricky to understand. There are lots of Wikipedia and other blogs where they explain this process very clearly. So you might want to read this, right? But today we will just simply solve this problem using Monte Carlo simulations. Okay, now I'll explain why the probability increased to 2/3. Okay, so let's say we are switching here, right? So we have made an option 2. So our initial options have 1/3 winning probability. Now, which means our probability of losing is 2/3. Okay, our probability of winning is 1/3 and our probability of losing is 2/3. Now the host has eliminated one of the doors, which means the remaining door has a probability of winning 2/3, right? So initially each door has 1/3 probability. Now the host has eliminated one of the doors, so that probability will be switched to, these two doors have 2/3 probability, right? The door which we have not selected. Now the host has eliminated one of the doors because he already know there is a goat behind, which means the other door will have a winning probability of 2/3. It's a bit tricky, but go to the Wikipedia page and read it. There are different ways of explaining it, and you will understand. Okay, so let's start the simulation. So we are going to run the simulation n number of times with a switch or without switch option. Okay, all right. So do the experiment. This is a function call. Here we are doing the experiment n number of times. And the first time, for example, we have made an initial selection. Now, after we made an initial selection, which is simply picking one of the 3 numbers, and then the host will make a selection, right? But at this point, what are the host options? When we begin, we have 3 options to choose from, and we pick one of the options. Now, the host will have only either 2 or 1 option to open the door. I'll tell you. So, for example, in this case, let's say the car is behind door 1 and the goats are behind door number 2 and 3. Now, let's say you already picked, you happen to pick door number 1. So then the host from 2 and 3, the host will pick one of the doors, right? So he might open door number 3 or door number 2 or door number 3. Now, what if you have picked door number 2 as your initial option, right? If you pick door number 2 as your initial option, because the host already knew that the car is behind door number 1, the only thing he could do is he opened door number 3 to disclose you the goat, and then he will ask, hey, do you want to stick with your initial guess of door number 2 or do you want to switch it to door number 1, right? So that's what we are doing here. So from all the doors, here we are removing the initial selection, okay? And then the host will have the 2 options. So the host will have the 2 options from the goat doors, right? So from the goat doors, we are removing our initial option. Now our initial option might be one of the goat doors or not. So if it is one of the goat doors, then the host will have only one door to open. But had we selected a car door at the beginning, then the host will have 2 doors to open, and he will pick one of the doors, okay? And from the host options, he will make a selection, right? So the host has made a selection. Now, after making the selection, the host will ask you, hey, do you want to switch or not? Now, let's say you are not switching, okay? If you are not switching, then your final selection is same as your initial selection, okay? Your final selection is same as your initial selection. So if we are not switching, the problem is very simple. So from the 3 options, you select an option. What the host does here does not matter because we are not changing our decision. So your final selection is simply your initial selection, okay? But let's say you decided to switch. So you are switching here. Now your final selection will be from all the doors which are there. Initially the 3 doors are there. You have made an initial selection. Host also made a selection, and now you have to make a selection which is not either of these, right? So out of these three, you are eliminating. Here we are eliminating two options. That means we left with only one door, right? So that's going to be our final selection. So for example, to explain this, what we did is, so let's say our initial selection is 1, the host has selected 2, and then the host gave you the option, hey, do you want to switch or not? Now our initial option is 1, so we are not remaining with that, and the host already disclosed there is a goat behind 2, which means there is only one option left, right? So our one option and final option is door number 3. Similarly, let's take this. So initially we have selected door number 3. The host opened door number 2 to disclose the goat, and then that means we are making a selection. So we cannot, we have to switch from 3. We cannot choose 2, which means the only option we have is door number 1. So that's what we are doing here. Okay. And then here we are printing what we just saw here. So what is our initial selection? What has the host selected? And what is our final selection? Now, if our final selection is equal to the car door, then we win the game, right? So we run this experiment many number of times, and here we measure how many times we win the game. And finally, the probability of winning the game is number of wins divided with the number of runs. Okay, so initially we run this experiment just 10 times so that we can see all this output, right? So what it would look like if we do not make a switch, and what it would look like if we make a switch. But these probabilities are incorrect because we have run the experiment only 10 times. Now let me disable this line and let me run the experiment many number of times. Okay, so here what we are doing is, our switch option is no, so we are not going to switch, and we are doing the simulation here for n number of runs with the switch option no, and then this function returns the probability of winning. So here we are printing the probability of winning, right? That's the first set of experiment. And this time we have decided to switch, so switch is equal to yes, and we are doing the same experiment, but this time we have decided to switch when the host asks us. Now again we are computing the probability, the function will return, and we are printing it. Okay, so let me run it. Oh, sorry. So let me run this function. Now we'll see. Okay, so if we stick with our initial option, as you know, it's a straightforward problem. The probability of winning is 1/3 because there are 3 doors and the car is likely to be behind any one of the 3 doors. So the probability of winning is 1/3 if we don't make a switch. But if we make a switch after the host gave us a second option, our probability of winning has increased to 2/3, right? From 1/3, it has increased to 2/3. This is a quite tricky yet very simple problem. As I said again, maybe if you want to think through, go to the Wikipedia page, and there are a number of blogs which explain this very clearly. Right. So to summarize, by switching the door, our chances of winning the game have doubled. Okay. That's all for today. Thank you very much.